Hi, good morning. Uh, just I want to introduce chapter 13, and I'm not sure if I will be able to finish it in one setting. I like to have short videos, they are easier to upload. All right. In this chapter, we are going to start a series of maybe three chapters talking about thermodynamics. Thermodynamics, it is the field that is going to study temperature, heat, and related quantities. In chapter 13, mainly, we are going to talk about heat and temperature. Also, we will introduce some of the ideas or, concepts very similar to the one that you got in chemistry about the ideal gas law. Now, of course, since I said heat and temperature, of course, this means that these are really two different quantities. And I will say, let's define first temperature. I will say one of the easiest definitions is talking about that temperature is a number or a state that is going to determine the direction of heat flow because naturally heat will flow from hot to cold. Then if I have my cup of coffee at 90 degrees Celsius and I have the room at 22 degrees Celsius, apparently heat is going to transfer from hot to cold. Now, more scientific notation, more scientific, I will say definition, it is relating the temperature to the average translational kinetic energy per molecule. We're gonna see in a little bit, how this can be verified using equations. Then here, if I have 1 liter of boiling water, which means, let's say, assume here for simplicity, I said 6 molecules. And then if I have 2 liters of boiling water, they are both at the same temperature, which is the 100 degrees Celsius. And, but like, the 2 liters have maybe, has maybe like 12 particles or molecules. And if I assume every particle on the left has 10 joules, then the particles on the right, they have also 10 joules because the temperature are the same. Now, the average kinetic energy, it is 1/2 mv average squared, where mi, it is the mass of one molecule in kilograms, and v is the average speed in meters per second. Now, one thing that also we need to know that there are three types of motions that in materials. The first one is translation, and translation meaning moving from one place to another. And there is rotation, okay, where there is an axis of rotation, and then that molecule is going to rotate about this axis. And there is vibration as well. Now, I will say temperature has to do only with the one type, which is the translational kinetic energy. Then it has nothing to do with rotation and vibration. On the other hand, heat is defined as the energy that is exchanged when there is a difference in temperature. Heat cannot be contained in objects. The objects cannot contain heat. We are going to talk also more about heat later, but just I want you to know that based on this definition, then we are measuring heat in joules. Okay? Um, Now, I need, of course, a way of measuring temperatures. Therefore, I'm going to use thermometers. We are mostly familiar with these are mercury thermometers, where we have mercury inside this glass and it's going to change its volume based on temperature. Now for, I will say, temperature scales, the first one was Fahrenheit, and it is considering boiling water at being like 212 degrees Fahrenheit, and the freezing at 32 degrees Fahrenheit. And here you can see that for the Fahrenheit, we have 180 divisions. When we compare it to Celsius, Celsius is considering 100 for the boiling and 0 for the freezing, and therefore it is 100 divisions. If I compare, we're gonna find that the size here for the Fahrenheit it should be less because more divisions. In order for me to be able to convert between Fahrenheit and Celsius, then I can say F equals the 9 over 5 C plus 32. I provided here an example where I was able to convert to 12 Fahrenheit, and then I can convert this into Celsius, and I'm gonna get the 100 degrees Celsius. What I did here is I put here 212, and then now here, in order to solve this equation, I subtracted 32 from both sides, and then here, this is gonna cancel it, and then 9 over 5C, and 212 minus 32 is 180. Then I was able to solve for Celsius to be 100 degrees Celsius. Now, I know that, there is an experiment which studied, the pressure versus temperature. More than one scientist did that experiment, and then there is a scientist who did that on gas A, and he or she was like, they found that type of trend online. And then another study was involving B, and then we got these results, and then C, these results. These are different gases, but when we extended the lines to cut the temperature, there was it was really intersecting at the same point, which suggested that we're gonna have something called absolute zero. Now, and therefore, the Kelvin scale was created, and the Kelvin scale, it is the official, I will say, or the standard unit for temperature. Okay, always, if we want to use a temperature in an equation, it should be in kelvins. Now, Kelvin is having what is called absolute zero, and the absolute zero occurs at negative 273.15 degrees Celsius. And to convert between Celsius and Kelvin, we say K equals Celsius plus 273.15 degrees Celsius. Or sometimes we're gonna make it easier by saying only 273. Here I'm showing you several examples about the conversion. I have here a tungsten light bulb filament that operate at 2900 Kelvin. What is its Fahrenheit temperature? What is this on the Celsius scale? I did not provide you here with any direct equation that is going to convert between Fahrenheit and Kelvin. Therefore, I'm going to first convert into Celsius. Then Celsius is going to be the Kelvin minus 273.15. And from that, I got 2600 Celsius, which is the answer for the second part. And also for the first part, I did use TF. The temperature in Fahrenheit equals 9 over 5 temperature in Celsius plus 32. And then I was able to solve and find that it is 4800 Fahrenheit. Something that I want to bring to your attention here is that when I did this calculation here, I got 2626.85, but for as the sake of significant figures, it was converted into 2600, because here we need to keep the lowest number of decimals. because it is subtraction. And here also TF, but when I want to use this to find the answer for A, I substitute the exact number so that I will not lose points when I round off. Then TF equal 9 over 5 TC plus 32, and then I was able to calculate this as 4,800 degrees Fahrenheit. Uh, the second question, at what temperature do the Fahrenheit and Celsius scales have the same numerical value? B, at what temperature do the Fahrenheit and Kelvin scales have the same numerical value? Here I will say I will solve the first one, TF equals 2C equals T, and from that I will say T equals 9 over 5T plus 32 because I assume they are equal. Then I'm going to substitute the same parameter, and then from that when I solve it, it's going to give me T equals negative 40. Okay, I'm going to stop here and have another video. Thank you.